Hello everyone, my name is Arbaz Kazi. As a part of Open Educational Resources for the FDP 201X organized by the IIT Bombay, on behalf of my team, I'll be presenting the topic of soil identification and classification. This topic will be focusing on the following points, that is, the learning objectives of the course, purpose of soil classification and identification, various soil classification systems adopted all around the world, which are particle size classification, textural classification, ASTO classification system, unified soil classification system, and Indian soil classification system. Also, we'll see the difference between all these types of classification system. So the first is the learning objectives of the course. So what will be this course helping any viewer once it is completed? So at the end of this course, one will be able to understand the importance of soil classification for developing any structure, may it be dam, may it be building, etc. We'll be able to understand the working mechanisms of the various soil classification systems. Apart from it, we'll be able to analyze the appropriate type of soil using any system. So the important first foremost point is the purpose of soil classification. Why it is necessary to classify soil. We know that soil exists in four states, namely gravel, sand, silt, and clay. But in nature, it is very difficult or rare to find these four types of soil everywhere. Now, for example, you can find pure sand on the beach, but in an area just few kilometers away from the beach, you won't be able to find sand. So, we can clearly uh, make a statement here that soil, even though exist in four different types, are not common everywhere. So everywhere around the nature, you will be able to see soil which is the mixture of all these four types, or either three types, or either two types of natural soils with fluctuating magnitudes. Second is, now we all know that animals are classified on the basis of carnivorous and herbivorous uh, characteristics. On the similar basis, soils should also be classified on the basis of similar behavior with simple indices. This classification will help an geotechnical engineer to predict the engineering properties of soil, like settlement, shear strength, bearing capacity, etc., and will be able to find out the nature of the soil, how it will behave when any structure is constructed on it. Third is, soil classification serves as a common language to the concisely defined common characteristics of the soil. So, in other words, we can say it will help, or it is a language for any geotechnical engineer to understand or to predict the other physical and chemical properties. So, there are various types of soil classification systems like particle size classification, in which we have US Bureau of Soil Classification System, MIT classification system, that is Massachusetts Institute of Technology classification system, BIS, Bureau of Indian Standard Classification System. Next is the textural classification system. Third is the American Association for State Highway and Transport Official Classification System. Popularly, it is known as ASTRO classification system. Next is the Unified Soil Classification System, and last is the Indian Standard Classification System. Now, first we'll talk about the particle size classification system. Now, as the name suggests, in the systems, the soils are organized according to the grain or the particle sizes. Terms like gravel, sand, silt, and clay are used to designate the different grain sizes in this system. The terms that are used are only used for the designation of particle size. They do not have or they do not indicate naturally occurring soil types. Last but not the least, plasticity characteristics have no role in this system for soil classification. So, as we discussed earlier, there are three main types of soil classification, particle size soil classification system: US Bureau, MIT classification system, and BIS soil classification system. Now, we have made a statement that these soils are classified on the basis of particle size. So, what is the difference between these three systems? So, if you look properly, the particle sizes that is used to differentiate the different soil types are different from other systems. Now, for example, in US Bureau soil classification system, particle size less than 0.05 mm is termed as clay, whereas case of BI soil classification system, the particle size less than 0.002 mm is termed as clay. So even though there is uh, particle, the classification is say based on the particle size, but the differentiation between the two soil types is different for different system. Means different particle sizes are used by the different systems for differentiating the soil types. Now, how we can use this system? For example, this BIS classification system for soil classification purpose. So, for example, let us take 1 kg of soil and we use sieve analysis uh, or different sets of sieves. So, from the results, we have find that the 80% of the soil is passing through 4.75 mm sieve, but it is retained on 2 mm sieve, and 20% of the soil is retained on 4.75 mm sieve. So it means out of that 1 kg sample, 200 grams of the soil is gravels, which may be either fine or either coarse, and 800 grams of soil is coarse sand in nature. So this is how the working of these three systems goes on. Limitations of the particle size classification. Now, as I have told you earlier, this system is gives us the border between the groups, that is gravel, silt, sand and clay, but it doesn't give the name for the bulk of soil. Secondly, this system is purely based on the particle size and does not consider plasticity characteristics. But in reality, plasticity characteristics have a great part in influencing the physical properties of the soil. Since mostly all types of soil in nature is in mixture, so this system may be ineffective for soil classification. Next is the textural classification system. Now, this system was developed by the US Department of Agriculture, USDA. Again, in this system, the classification is done purely on the basis of particle size. But the particle sizes are fixed in this system. That is, the sand should be between the size of 2 mm to 0.05 mm in diameter. Silt size should be between 0.05 mm to 2 micron in diameter, and clay size should be smaller than 2 micron in diameter. And since again I have mentioned this point that this system only uses particle size for classification, this system is mostly used for classification of coarse grained soil. For classification of fine grained soil, this system is ineffective. Now, this is how the textural classification is done. There is a triangle where the three vertices of the triangle resemble the different soil types, that is clay, silt and sand. Apart from it, the area or region in of the triangle is divided into 12, which resembles the different soil types like sandy clay loam, etc. So how one will use this system to find out the exact nature of the soil or exact classification of the soil. So let us take an example. Now from sieve analysis result, I have 30% of the soil as sand, 30% of soil as silt, and 40% of soil as clay. So what is to be done? I'll mark 30% point of the sand vertices, and parallel to the clay vertices, I'll make a line passing through this 30% point. Similarly, I'll mark 30% on my silt vertices, and again through the sand vertices I'll make a line parallel touching the point of 30 of the silt vertices. Similar will be done for the clay. Now these three vertices or these three lines when are joined, they will intersect at some region. Wherever these three vertices or key intersect or meets, that is the soil type for the given specimen. So for the given example, the soil type is found out to be clay. Next is the AASHTO classification system, or American Association for State Highway and Transport Official Classification System. Now, this system was originally developed by Haugenthaler and Terzaghi in the year 1929 as a US public road classification system, which was used for the design of highway subgrid. Now, last two classification system, that is particle size and textural classification system, was purely based on the particle size. But the American AASHTO classification system is based on both the particle size as well as the plasticity characteristics of the soil. This system is mostly adopted for the design and construction of the pavement. This groups comprises of 7 primary groups, and again few groups are further divided into subgroups. So we'll see or discuss about the AASHTO classification system in the next video. Thank you for watching.